Hi, welcome back again to Mrs. Thompson's classroom. Today we're going to be looking at quadratic functions. If you're in class with me, we're now in chapter 3. So we're going to be graphing these functions. They're going to graph parabolas, so they'll look U-shaped. We're going to find their mins and maxes, and then we're going to do a couple of word problems as well. So let's get started here by just looking at the basics of a quadratic function. Okay. So as I said, they graph a parabola, so they'll look like this. The equation is ax squared plus bx plus c. This would be standard form. Okay. And then in work form, it looks a times x minus h squared plus k. Now, if you remember your rules of transformations of functions, this minus h is going to be moving the graph left and right. The k is going to be moving it up and down, and of course the a tells us if it has been stretched or shrunk, so that'll tell us how steep the curve is, and of course whether it's going up or down, because a negative a would flip it over. Now, let's look at this specific one real quick. Here's the vertex at 2, 1. That is our h, comma, k. Okay, so for this particular function, we'll have y equals, and then x minus 2 squared plus 1. And then we'd have to figure out what a is. We do know that a is positive because it's going up. Okay, now all parabolas also have what's called an axis of symmetry. We notice that they can be folded in half along that line. So if it's a vertical parabola, like all the ones we're going to be doing today, it would be at x equals 2 for this specific one, and in general it'll be at x equals h. Okay, so let's take a look at another one. We want to find the vertex and we want to graph the equation. So the first thing I notice is I can find h and k. All right, so my vertex is at 3, negative 1. So I'll start by plotting that point right here. My a value is greater than 0, so it is going to go up. Okay. And then I need to figure out a couple of extra points. So I'm just going to pick an x and calculate y. I'm going to pick an x near my vertex. So let's plug in 2 and 4. So if I plug in a 2, I'm going to get 4 times 1 minus 1, which is 3. So 2, 3 would be right here. Now, my axis of symmetry is at x equals 3, so that's going to come right here. That means this point should flip across that axis, and at 4, I should also get 3. Okay, so if I put a 4 in here, yes, indeed, I get 3. So then I can just connect my dots. And I have graphed my parabola, and I have labeled some points, label at least 2 or 3 of them so that the graph is readable and we know what our scale is. Okay? Now, that one was in work form. What if it's not in work form? Well, then I need to figure out where the vertex is. And there are 2 methods. One method is to use completing the square to get it into work form. So that's the method I'm going to use on this one. So I'm going to have y equals. The first thing I'm going to do is I'm going to factor the 2 out. I am going to leave the 6 sitting there by itself. Now, my point in doing this is to get this to where it factors to a perfect square. Okay, so what goes in the blank to make this a perfect square? Well, I'm going to take the middle piece, the 4, the b value, divide it by 2, and square it. So that means I'm going to put a 4 here. Now when I factor x squared plus 4x plus 4, it becomes x plus 2 squared. Okay, that would get me back to the square root. It gets me back to what's inside here. Okay, now what have I actually added into the equation? Well, the 2 multiplies into those parentheses, so what I've actually added is 8. So I need to add the 8 to the other side as well. So I end up with y plus 8 equals 2 times x plus 2 squared plus 6. And then we can subtract the 8. Or, of course, you could just put minus 8 on the right side to begin with. So now my function is in work form, and my vertex is at -2, -2. So that's here. We can know our axis of symmetry is at x equals -2. And then I can pick another x near this axis of symmetry. So let's say -1. And I can plug it in. Now you can plug it into the work form, or you can plug it back into the original equation. So I'm just going to plug it back into the original. And I'll get 2 minus 8 plus 6, which is 0. Now my axis of symmetry is here. So this point is going to flip across to -3, 0. And then I can connect my dots. Okay. Now, the alternate method, if you don't like completing the squares, is more formula-based. So you notice that when we completed the square, we took the b value and we divided it by 2 and we squared it. So we're still going to take b and we're going to divide it by 2. Okay, but also notice when we completed the square, if you look back, this sign here determined what sign went here. But notice that that gave us the opposite sign in the end result. Okay, so I want to take -b. Now also notice in the example we did with completing the square, we wanted this leading coefficient to be 1. Well, one of the ways I deal with having to factor out that first is by putting the a value in here. So my h value of the vertex is going to be -b over 2a. So in this case, that'll be -6 over 2 times -1, so that's 3. Then I find k by finding the y value at that x equals 3. So I'll have negative times 3 squared plus 6 times 3 minus 5, which is 4. So my vertex is at 3, 4. Okay. Now the other thing I notice here is that my a value is -1, so it's going to go down. And then my axis of symmetry is at x equals 3, so that's here. So now I'm going to choose a point. So let's choose something near 3, so I'll plug in a 2. So I have -2 squared plus 6 times 2 minus 5. So that's going to equal 3. So I would have that same value on the other side of the axis of symmetry at 4. It'll get spun around. Okay, so then I have my parabola. If I connect my dots. Now, of course, if I want to be more precise, I could plot more points. So maybe I actually also put in an x of 1 or an x of 0. The more points I plot, the more precise my graph gets. Okay? All right, now every parabola has either a bottom, if a is greater than 0, or it has a top, if it's less than 0. So all of them have a min or a max, and these are actually absolute min and maxes as well as relative or local. So let's say I have this function, and the question is to find its min or max. And so what I'm going to do is I'm going to find that h value. So that'll be 5 over 2 times 2. So that's at 5/4. So that's where it's occurring, is the x value. I know that it's a minimum because my a is positive, so it's going up, so I have a minimum. So the next thing I need to do is find its value, so I need to find k. So 2 times 5/4 squared minus 5 times 5/4 plus 6. And if you take a moment to plug that into your calculator, what you end up with is 23/8. So your minimum value is that x equals 5/4, and the minimum value is 23/8. Okay? All right, now let's take this and put it in a word problem. Now this particular problem is sort of a physics application. We're throwing a ball in the air, so we're doing projectile motion, and projectiles always travel in the path of a parabola. The 4.9 is coming from half of gravity, that's the acceleration. The 15 is related to our initial velocity that the ball is thrown with, and the 5 is the height from which it's thrown. So I've got, this little person, say me, at a little over 5 feet tall. I throw a ball and it goes, and eventually it's going to hit the ground. The question is, where does it reach its maximum height? So the first thing I do is I find h. So I'm going to have negative 15 over 2 times negative 4.9. And when we calculate that, we get 1.5306. And it actually keeps going. That's not the end of that decimal. So when I do further calculations, I want to use my calculator and keep as many of those decimal places as possible. Okay, now this is just when it's occurring. This is at this many seconds because it says time is in seconds. Okay, so now I need to find the k value. So I'm going to find f of 1.5306 ... So I'm going to put that in my calculator, and what I end up with is 16.48 meters. Okay, so that's this point right here, 1.5306, 16.48. I have found the maximum and when it occurs. Okay. Now for question B, it wants to know when it hits the ground. It wants to find this point. So that means I'm going to take the formula, the function, and I'm going to set it equal to 0. Well, this is a quadratic, and I'm finding its root, so I'm going to just use the quadratic formula. Okay, now this is going to give us 2 answers, plus or minus, but of course we only want the positive one because if we get a negative time, well, that means we went back in time, and that's not going to happen. So if I plug this in, let's see, we're going to end up with 2 results. I'm going to have negative 0.303 and 3.365. So this is the time at when it's hitting the ground, seconds. Okay. All right. Now something else that we can use quadratics for, this problem doesn't really look like a quadratic on the surface, but let's see why we end up with one. So I've got a rectangular field that John is trying to put fence around. And we've got 500 feet of fence. So that means that the perimeter cannot be any more than 500. And if we want to maximize it, we're going to use up all that fence, okay? Now we're trying to maximize the area, which would be x times y. I've got two variables. I can't really solve with two, so I'm going to have to try to do some substitution. So I'm going to use this first equation and solve for y. Okay? Now I can plug that back into my area equation. And then I can find the vertex. So the vertex here will be at h equals negative 250 over 2 times negative 1. So that'll end up being 125 feet. That's my x value. Okay, and I know it's the x value because that's the variable I have right here. Okay. Now, if I want to then find y that corresponds with that, I get a y value of 125 feet as well. Now, it makes sense to maximize a rectangle. We're going to make it a square. But this is the algebra that shows us why that is. So it's good to go through the process and not just make assumptions, because sometimes they may tell us that he already has a barn here and he doesn't have to use that fence. Or there's a river here that he wants to put on it so the cows have water or something. So we don't want to just assume it's going to be a square. We need to go through the math and prove to ourselves that that's what it is. So, okay, hopefully this is making sense. Do some practice with your quadratics. Next time we will look at higher order polynomials and figure out some ways to graph them just with the basic knowledge that we have. And so hopefully I will see you then. Be sure to comment down below if you have some questions, or if you're in class with me, look over your practice problems and bring your questions with you when you come. See you next time.